So question 6 it states an electron in the n equals whatever energy level of hydrogen absorbs a photon of a certain wavelength. Find its kinetic energy after being ejected from the hydrogen atom if it is opposed or attracted by a potential of a certain amount of volts. Okay.
Wait.
So
This divided by the wavelength.
So in this problem, what we're going to do, the first thing that we need to find is the kinetic energy when it is ejected, which is just the energy of the photon, which we can once again find either by hc over lambda or hf. In this case, since we have a lambda, we're going to use hc over lambda.
It's not MeV.
Plus the energy of the electron. But the energy of the electron in the hydrogen atom is actually negative because it's holding it in there. So basically these are two opposing forces. The energy that is kicking the electron out of the hydrogen orbital, and then the energy that's basically keeping it in the hydrogen orbital. So when I rewrite this equation, our photon will be hc, so I'm just going to do hc, actually hc up there, she already wrote it. hc is 1240 electron volts per times meter squared. And so we'll just divide that by our lambda, which is 300 nanometers. And then add that to negative 13.6 divided by, divided by n squared. So does everybody remember this equation here, this small equation? Okay, so this equation is just the energy of an electron in whatever, in orbital of hydrogen. So if n equals 1, your energy would be 13.6 electron volts. Okay? But since n equals 2, this equals 2 squared. Okay, so all you have to do in this is just divide 2040 by 300. Which we don't have. And that will equal 2. I don't know what this number is. I need to. 4.83.
1.13.
0.13. 4.13.
Yeah.
Okay. And this is 3.4. I know that. Or at least it's something close enough. So
0.73.
0.73. Okay. So this whole thing that we just did was just to find the kinetic energy, which equals, you said what? 0.73. 0.73 electron volts. Okay. So once again, this is the kinetic energy of the electron after we have ejected it from some orbital of this hydrogen atom, this n equals 2 orbital. So now what we have to do is find the kinetic energy when it is striking some sort of plate that's giving some sort of potential. So in this example, I'm going to say that it is attracting the electron, and therefore the potential is negative 2.5 volts. Okay, and the reason it is a negative is because when we do this equation, so I'm just 0.73 electron volts, this Q is the charge of the electron, which is negative 1.6 times 10 to the negative 19 joules. And then our delta V is negative 2.5. But we want this in electron volts. And so once again, we're going to divide by 1.6 times 10 to the negative 19 joules per electron volt. So basically, the only reason that I'm making this negative is because we have a negative charge. And so the potential is actually you have to have a negative charge to make the potential, right? So I'm not gonna say anything more to confuse you. So basically, when you're doing this, all you have to do is just add 2.5 electron volts. So in the end, you're gonna end up with 3.23 electron volts. Now, the other way he could do this, because he does have a possibility that it could be opposed by some sort of potential, is he could give this frequency, wherever it is, he could give the frequency to be really high, or basically this wavelength to be really, really short. So this number is really high, and then you'll end up with a really high. Let's say you end up with like a 5 electron volt kinetic energy when it gets ejected. He could then say it is opposed by a 2.5 volt potential, in which case it should be positive 2.5. And in that case, this then would become whatever 5 electron volts minus 2.5. In which case you'd have 2.5 electron volts. So that's the other way you could do it. Otherwise, you would never strike the plate, and the question wouldn't make sense. So, so he's either going to have something where you have a negative voltage, which is basically a positive potential. It'll make it speed up. Or you'll have a very fast speed to start with, and then he'll have something opposed, most likely. Okay? Good. Cool. So that was number 6.
We're ready for 5 whenever you
Okay, go ahead and do 5, because I need
you want to. Okay.
I need to